Good afternoon. This is my financial disclosure, and I have to say I'm honored and very privileged to work with OCULUS for long years. This is also acknowledgement for my colleagues from Brazil and also from Portugal. And when we talk about the quest for enhanced ectasia detection, the main issue on this editorial is to go beyond but not over. Not over detecting mild forms of ectasia, but detecting the susceptibility for ectasia development using front surface curvature. It's very important to understand the imaging technology has evolved into the biomechanical properties characterization. I was fortunate to train with Steve Wilson, who is a clinician scientist, who gave us a lot of information about wound healing with his studies. And B.J. Dupes and Cynthia Roberts has done over the years a great work to let us understand the importance of corneal properties for refractive surgery. So when we talk about the visualization of the corneal deformation, it's really come to be key that you have to go beyond the visualization of subjective parameters. If you see a keratoconic cornea, they are superimposed in time, it starts to deform earlier, it goes much more depressed, you have more oscillation. But we need to have objective data. And the Vinciguerra screening report is great, and as Cynthia said, we are very proud for Riccardo for his Trautmann Award this year, later in the Academy next month. So the detection of the understanding of the enhanced susceptibility has to integrate shape and biomechanics. And that's our work in Rio de Janeiro, and we came together with this display in which we have the stiffness, you have art age, you have integrated radius, and you see how the cornea is that we measure in terms of the bell curve. This display combines tomography and biomechanics, and the TBI gives you a number. So if an image worth 1,000 words, a number would worth 1,000,000 images. So it's important to understand basic concepts for corneal diagnosis. You have to be objective, front surface curvature, tomography, biomechanics, wavefront and axial length, they may play a role as well. We need to understand the populations, disease and no disease, do the ROC curves, as Riccardo just mentioned, and combine those indices. Many indices using artificial intelligence. We use cross-validations and external validations before clinical implementation. Variability is important. This is a study that we sent 25 topographies from the Pentacam for 11 colleagues, and the variability of the classifications using the Brad-Randleman criteria was very high among experts. We sent the same topographies using another scale. The first one was the absolute Steve Kleist scale, and now with the 0.5 scale, the same examiners different from themselves in 9 out of 11. So it's important to see the variability. Fernando, when he was working with me a couple years ago, he put together this table that you have many of the objective parameters from the Pentacam with a subjective, objective evaluation of cutoff values, ROCs, and sensitivity and specificities. We need to be objective, so we have these parameters from the Corvis, and the integration is what we should do. The populations, the studies on the CBI that we just seen, they are very important for us to see keratoconus with disease, clinical disease versus no disease. But we now have an opportunity to see the subclinical disease. A lot of people ask me, do we need topography and is it enough? I think we still need topography, and we come on that on the end of the talk, but the sensitivity is very high for topography to detect cases with 20/20 best correct vision in this patient. But the fellow eye of this patient also gives you the idea that the fellow eye with no topography abnormality would come with the idea that it's not so sensitive. Not to mention the specificity, because we have cases with abnormal topographies that have done LASIK for many years and they're still stable. We need to be objective, and we have the Rabinovitz criteria for being the objective criteria of saying those corneas were topographically normal in the study that we've done. And even though some of these cases, here again using the 1.5 absolute scale, you see some cases that are still a little bit of suspicious, but they came as normal with the objective criteria that we selected. So this study looked at artificial intelligence for understanding the diagnosis of ectasia, and we have multiple ways of separating using leave one out cross-validation, so that we have the best parameters that would be compared to the bad D, the bad DI, and later with the CBI that was developed in the study. Separation curves with the normalized values as proposed by Jens Buren is a great tool to understand what is a better parameter than the other. And the dot plot graphs talk to themselves. The bad DI is a concept that I think it's important to mention, so that we understand the DI is an index that will come from 0 to 1, and the bad D has a continuous from negative values to positive values. So the bad DI will be a better way to correlate with the other parameters that come from 0 to 1 as well. From the many artificial intelligence ways to calculate the tomography and biomechanical integration, the random forest with leave-one-out cross-validation came to be as the best one. And you see here the bad DI, which is exactly 100% correlated with the bad D, the CBI and the TBI. And you see the separations here are much easily seen with the tomography and biomechanical index. So with 480 eyes from each of these patients randomly selected with normal topography and tomography, 204 cases with clinical keratoconus in both eyes, again one eye randomly selected. We have also the 94 cases with one eye presenting with ectasia and the fellow eye presenting with normal topography, again with the objective criteria. So we see the separation from normal and abnormal is clear-cut with 100% sensitivity and specificity. We have 90.4% of sensitivity on the detection of the normal topography eyes, still with 96% specificity. So it's important to understand that I believe this is a continuous from stability towards abnormality, and we need to understand the ectasia susceptibility, and I think this index epitomizes this type of parameter that we want to have. Again, this is published in the JRS recently this year, and is one of the mostly seen papers in the JRS as seen previously in this month. External validations are very important. External validations have been something we've been working for many colleagues. They're great people that are motivated for doing good work from India, Iran, Germany, Portugal, Brazil, and Italy. And I will cite a couple of these papers. Prema Pradhamada from India, she sent us 100 cases with a keratoconus mean K less than 48, so mild keratoconus. And you see the CBI that was actually validated by this study as well, the good performance of the bad D, but the very nice separation here for the TBI. We also have Momeni from Iran, who sent us 24 very asymmetric cases with normal topography in one eye. And you see the abnormal topography eyes were very, very nicely selected here. And for the normal topography eyes, we have 91.7% sensitivity. 2 out of 24 came as relatively normals. We did a study in Rio from the cases that after doing the TBI, that they were not part of the study for the original TBI creation. So Jose Mendes from Portugal, he was visiting me, and he got a very nice work for selecting the normals, the keratoconus, the very asymmetric cases. And you see that in the very asymmetric cases with normal topography, you still have 86.5% sensitivity. One of the cases that we selected as asymmetric ectasia came a little here. And this makes us think a lot. In the global consensus, we have one consensus, and I put Yoda here, who is the epitome of wisdom in our people who like Star Wars, would say that this is a true keratoconus unilateral does not exist. We also came as a consensus that secondary ectasia that could be caused by a pure mechanical process, like the case that Vinciguerra just presented, can be unilateral. So this is probably the best unilateral ectasia case that we have. This patient presented with keratoconus in the right eye, a keratoconus phenotype in the right eye, and a normal everything in the left eye. It was normal wavefront, uncorrected vision 20/20 plus. This patient did very well with intracorneal ring, and he moved to London. When he moved to London, I have him seen by Dr. Renstein in London with all this equipment that he has done, including the Artemis and the Orbscan. And interestingly, all the data was congestion with a normal in the left eye. So epithelial thickness, the Gatinel SAD score, everything normal. And we had the patient being analyzed retrospectively. We got the data, and we get this patient with the normal CBI, normal BAD-D, and normal TBI. So this is true evidence that everything is making sense, and he really had an opportunity to understand that he had unilateral disease. I don't think it's keratoconus, but unilateral ectasia. This is a patient that had LASIK only in the left eye. The right eye was not operated, and she would qualify for LASIK. And we published about 7 years ago the Tomography and Biomechanical indices, and we got the concept of ectasia susceptibility. This is not keratoconus or form fruits keratoconus. It's a clearly normal patient with 2015 best correct vision. She's still stable, and when she comes for a follow-up, she was everything normal in the right eye. And you see different scales. Even with tomography with the quad maps, everything is normal. The BAD-D is on the yellow range like what we saw a few years ago when we published. But interestingly, the TBI came to be 0.83, and this patient was not part of any of the algorithms for the training system. This is an even more interesting situation. This patient with subclinical keratoconus presented first, and she said, I have a twin sister, identical twin sister. So here we have 4 eyes with the same genes, and only one of these eyes have abnormality. You see topography from Placido and topography from the Scheimpflug using the Steve Kleist scale absolutely exactly the same. The TBI is abnormal in all the 4 eyes. And she admitted that she rubbed more than her sister, and she admitted that she rubbed the right eye more than the left eye. I think a couple words on Placido topography is still necessary, especially because we are in the land of Antônio do Plácido da Costa, a little north from here in Porto, with a beautiful city. In 1883, he developed the topography-guided topography system. The Keratograph 5 looks at topography in a much wider range of imaging technology, and this is a case that clearly gives us the impression that we still need to do very nicely work with the ocular surface. This patient is a contact lens intolerant. 3 days out of the contact lens, she has warpage. She also has dry eye. The warpage can be tomographically characterized and biomechanically characterized as well. 0 and 0 CBI. Interestingly, I showed this picture to many of my colleagues that are ocular surface and corneal specialists and asked them to look at the meibomian glands, and they all look here. They say it's even hard to get a good focus in this type of the part of the eye. However, the glands are here, and you can see with the infrared camera how the pathologies are going, and it's going to be critical for the follow-up. So, when we integrate, we have to understand ocular surface, ocular disease, and advanced corneal imaging are very important. We need objective analysis. We need to understand the enhanced screening that we should do for ectasia, and Scheimpflug integration today is the best way for us to get those very mild cases. It's important to understand that screening is different than diagnosing, which is different than staging and eventually prognosing for the patient. Ectasia susceptibility characterization is what we try to do here, and integrate with laser vision parameters is fundamental so that we can see what's safe for that patient. Corneal imaging has gone through a true revolution, which is still in evolution, and I'm very glad to collaborate with OCULUS to provide for us clinicians the answers that we have to improve the care for our patients. Thank you.